Okay, so we're gonna try a AC fundamental question. This question could really pop up on the FE or starting question on the PE fundamentals, right? Um, PE exam or the FE exam, electrical and computer. So the question is basically if a peak sine voltage V sub P of 250 volts is connected across a 320 ohm resistors, right? So if they have a voltage source here, 250 volts is connected across some resistive load of 320 ohm resistor, right? In a resistive circuit, what is the power dissipated by the resistive element? So this is the resistive element, the resistor 320 ohms. To do this question, they're trying to stipulate that we gotta get this peak voltage into RMS voltage. How do we get this peak voltage into RMS voltage? As we seen earlier in the video, the peak voltage is equal to this peak voltage upon the square root of 2 should give you this this VR MS. This is the V effective voltage, right? They did give us the value of the effective of the peak voltage. So the V effective or VRMS voltage is equal to V peak over root 2, which is 250 volts, divided by root 2. Right, so let's try that. 250 volts divided by square root of 2 works out to be 176.77 volts. Now, they're asking for the power dissipated by the resistive element. So the resistive element is 320 ohms. So we gotta pull an equation that deals with the resistance and the power. So the power is equal to V squared over R, particularly VRMS. That's why we get it from the peak voltage into the RMS voltage, because we're looking for the effective or the RMS voltage, which is useful power, like an average. Well, I would say the effective voltage, which is the RMS voltage. That's what you're gonna use for the power calculation, and you use V squared over R, right? So that V RMS squared voltage over the resistive element. So what's that voltage? Is 176.77 volts divided by the resistance of 320 ohm. So that's 176 squared divided by 320 ohms. Alright, so let's try that. So that's 176.77 squared divided by 320 equal, and that works out to be 97.65. Right, watts. So the best value is here 97.7 here, so it makes our answer B.